So here we have RSK Terrafix's fully relocatable, scalable, continuous pyrolysis system. So it's the only one in the UK. We traditionally work on wood chip, and we feed that at a rate of 1 cubic metre an hour, which is around 176 kgs. So that then passes up into our hearth, which is a multi-deck hearth. The feedstock passes from the top all the way to the bottom, duration of about 100 seconds. In doing so, it reaches temperatures about 700 degrees. As it reaches those temperatures, it produces syngas. Those syngases carbonise the incoming material. Then that incoming material is discharged at the base of the hearth into a third container as biochar. So the syngas that's produced during the carbonisation process is drawn off into a thermal oxidizer. That draws off all the volatiles. In the thermal oxidizer, those volatiles remain for about 2 seconds. They cycle and they're combusted and destroyed at temperatures of about 1200 degrees. And then when using pure wood chip, you're able to vent then straight to atmosphere well within regulations. Now, the biochar that's discharged into the third container is a wonderful material. It has many properties as a soil amendment because it has an alkali liming effect on the soil. It increases soil cation exchange capacity, readily available nutrients for the plants. Okay, but what's wonderful about the biochar is it's able to lock away or sequester carbon in a refractory form for millennia. So our system within real time is sequestering carbon on millennial timescales. So you've got that benefit of the carbon being locked away in the physical material, then you've got the physical material as well that can be used for all those purposes. And there's many more, there's hundreds, there's more being discovered every day in terms of plastics and things like that. So our system allows us to be deployed at the point of waste creation. You can put it straight into those systems, it can be dried on site, and then it can go straight into our system. You're reducing all those bulk handling, all those lorry loads, etc., etc. So in terms of wood chip, we can reduce volumes to about 75%, 80%. So again, that saves you money as you're moving forward, and all the carbon that you're saving in terms of all those movements. So what we're doing here at WRC in Swindon is the UK's first continuous pyrolysis system working on sewage sludge. And when we're talking about sewage sludge, we're talking about advanced anaerobic digested sewage sludge, which the industry called biosolids. So these biosolids have gone through that whole system at the water treatment sites, and most of the energy has been taken out to produce biogas. So what we're doing is taking those materials and thinking, how can we then utilise those for further waste management? So we're working as part of the Interreg 3C project with our European partners, with Severn Wye and with Welsh Water, Dŵr Cymru. Our system, with wood chip, you can safely and well within environmental regulations vent to atmosphere. But because we are focusing on biosolids, we now need to clean those emissions. So what we have is a nice flexible ducting that takes the syngases from about 400 degrees, passing into our condenser. They're then reduced down to 80 degrees. Those gases then pass up into our wet scrubbing tower. So our wet scrubbing tower, at the moment, we're optimizing with magnesium hydroxide. Now, magnesium hydroxide is a standard dosing chemical within the water sector. We're using currently a ratio of about 2.5% weight. So that magnesium hydroxide dosing liquor removes the sulfur dioxide from the gas stream and puts it into the liquor drum down here. The syngases then continue their journey through the piping system into an activated carbon filter, which is the final cleaning process, and then they're vented to atmosphere well within regulations. So in terms of when this is deployed to a water treatment site, the closed system would be that you use the liquor that you've removed the sulfur dioxide into, can be used as a quenching medium for the biochar. So the biochar can then fix those chemicals onto the surface and then within the structure of the biochar, so there's no waste. But also you substitute the activated carbon for the biochar you're producing within the system. So you're using that biochar you've produced from the biosolids to effectively clean any of the emissions coming off from the biosolids. So the whole goal is to be a fully closed system that is deployable small scale or large scale onto a water treatment site. But we can't put them through our system at the moment, just pure biosolids, because by producing the biogas, it's taken all the energy out, but our system requires around 13 megajoules per kilogram to be fully autothermal. So we're looking at finding the optimum blend at the moment with wood chip, because we know wood chip is clean. So we're looking at ratios of 20% biosolids to 80% wood chip, even 90% biosolids to wood chip, and finding that sweet spot that we know can pass through our system, maintain all the temperatures, produce high quality char, and then is well within regulations. So what our system does is takes those biosolids, produces a biochar, but in doing so it destroys the PFAS, it destroys the pharmaceuticals, it destroys the micro and nanoplastics, it destroys the pathogens. So in terms of regulations, biosolids is likely to be banned going to land in the next couple of years. So what are you going to do with these materials? You're going to send them to landfill most likely. That's what a lot of companies are looking at. So our system reduces the volume by about 90%. So even if you wanted to send the biochar to landfill, that's fine, you've reduced the volume by 90%, so you've got savings there. But what we can do is we can demonstrate with our system that you destroy all those pops, you're reducing the volume, but also the heavy metals that are concentrated in those biosolids are immobilized within the biochar. So you can safely deploy these biochars to land, which you can't do with biosolids. So that's the long-term solution. You are producing a biochar that is sequestering, locking carbon away for millennia. You're producing a material that can go to land, well within regulations, that immobilizes heavy metals, has available plant nutrients, but then you're also reducing the volume. You've got all those cost savings as well. So that's what we're looking at now, and so the next stages are going all out, full scale, 100-hour, 72-hour trials as Welsh Water see fit.